Hi and Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to present about our database project. The title of our database project is Kindergarten Management System. So, my name is Nurin Balqis, binti Husain.
Hi, Assalamualaikum. My name is Safeda Isnadira, binti Ishak.
Hi, Assalamualaikum. My name is Dayana binti Ahmad Sabri.
Hi, Assalamualaikum. My name is Farzana binti Mohamad Fathi.
Hi everyone, my name is Saidahtul Izzati binti Sazali.
So I'm going to start our presentation with the introduction of this case study. The case study is about Pusat Asuhan Tunas Islam Kindergarten Al-Muhaimin, which is Fathi Al-Muhaimin Management System. In this study, the problem of this kindergarten is the system they are using, which is manual. It is hard for them to keep track on the record and may lead to data loss. Because of that, they need to have a system to make it easier to access the data. We want to develop a database for the kindergarten to make it easier for them to access the data, and the teachers as well as the parents can access the system to look for many information. The teachers can access the students and their parents' information. Thus, the teachers could also keep the records of fee payment that has been done by the parents. The teachers can also search for the parents' information in the system. This system is very useful for the teachers to look at the parents and the students' data or information. Fathi Al-Muhaimin Kindergarten will not be worried about the data loss anymore because the system will back up the data. Next, we will move to the database design.
Now is the entity relationship diagram. Our title is Kindergarten Management System and the domain is Student Management. There are 7 entities in this ERD, which are student, class, subject, teacher, parent, fee, and group. The relationship between student and group is strong relationship, and the relationship between group and teacher is also strong relationship because in the entity group there are composite key which are teacher ID and student ID. Other than that is weak relationship.
So now we move to the third normalization form relational schema. Okay, for the third normalization form, it should be in second normalization form and it should not have transitive dependency. So we have the third normalization form like this. Okay, so for the first table we have student table. Next we have class table. Then we have subject table, teacher table, parent table, fee table, and also group table. So for the group table, we have composite key, which we have teacher ID and student ID as both primary key and also foreign key. So that's it for the third normalization form relational schema.
Okay, now I'm going to present how to create table for teacher and table for class. So the first table is table for teacher. So the first statement you must insert is create table teacher and then open the bracket and then insert all the attribute in the table teacher. You must insert it like this: attribute data type, comma, attribute data type, comma, attribute data type, comma. You go on like that. So just like this. After you open the bracket, you insert teacher ID, the attribute, and then char 6. This is the data type of the teacher ID. Not now, comma, teacher first name, varchar 15, not now, comma, teacher last name, varchar 15, not now, comma, teacher phone name, char 15, comma, teacher address, varchar 60, comma, and then after you already insert all the attribute in the table teacher, you write the primary key. Okay, right? Okay, primary key, and then in the bracket you put the attribute that is the primary key at the table. Okay, the primary key in the teacher table is teacher ID. Okay, after you close the bracket, and then you put another close bracket for the bracket you open just now at the first. Okay, then okay, that's all the SQL for create table teacher for table teacher. So at DB2, after I already create the table teacher. So you just run select stuff from teacher and then run, and then you get this output. This is the table for teacher. Okay. Another table is table for class. Like just now. Okay, the first statement you must insert is create table class. And then open the bracket, and then you insert all the attribute in the table class. Attribute, data type, comma, attribute, data type, comma, go on like that. Okay. The attribute is class code. And then char 10 is the data type in the at class code. So, okay, char 10 not null, comma, class name varchar 20 not null, comma, class time varchar 10 not null, comma, class section char 10 not null, comma, class capacity char 10 not null, comma, primary key. Okay, after you insert all the attribute in the table class, so you must write the primary key of table class. Okay. Okay, you insert primary key, and then in the bracket is the primary key at the table class. Okay, the attribute that is the primary key in the table class is class code, and then you put another close bracket because you already open bracket at the first. Okay, after you run this SQL for create table class, we'll get this output. So in the DB2, after you already create, you just run select stuff from class. You also get the same output for table class. Okay, this is the output for table class. Okay, that's all.
Okay, for table student, in table student there are 6 attributes, which is student ID, student first name, student last name, student age, student information, and class code. Okay, for student information, the information in the table, if the student have disease or allergic, so the teacher will alert to it. Okay, so to create table student, the command is create table student in bracket student ID char 10 not null, student first name varchar 20 not null, student last name varchar 20 not null, student age char, student information varchar 50, class code char 10 not null, and for the primary key student ID, and foreign key is class code, references to class
Student. So we run it on DB2. We select all from student. Okay, this is all the data for the student. Okay, student ID, student first name, student last name, student age, and student information, and the class code for the student. Okay.
Okay, for table parent, there are also 6 attributes in the table, which is parent ID, parent first name, parent last name, parent phone number, parent occupation, teacher ID. Okay, for the command is create table parent, in bracket, parent ID char 6 not null, parent first name varchar 15 not null, parent last name varchar 15 not null, parent phone number char 15, parent occupation varchar 15 not null, teacher ID char 6 not null, primary key parent ID, foreign key teacher ID, references teacher.
Okay, we run it on DB2. Okay, this is all the data of parents. There are 15 parents. Parent first name, last name, parent phone number, parent occupation, and the teacher ID that assists the parent.
In table fee, there are 5 attributes: fee ID, fee amount, fee transaction type, fee description, and parent ID. Fee transaction type is whether the parents pay the fee online or cash, and the description is is what fee the parents are paying for, whether daycare or anything else, and whether is it deposit of the fee, they pay the fee full. Okay, the command to create table fee is create table fee, bracket, fee ID charting not null, fee amount decimal 82 not null, fee transaction type voucher 50 not null, fee description voucher not null, parent ID is not null, primary key fee ID, foreign key parent ID, references parent.
For table fee, we run it on DB2, select all from fee, we run. Okay, this is all the fee in the kindergarten. One fee ID refer to one parent, and each parent have one fee ID.
Table subject, we have 6 attributes: subject code, name, subject hour, subject description, teacher ID, class code. The primary key is subject code, and there are 2 foreign key, which is teacher ID and class code. For the command to create table subject is create table subject, in bracket subject code char 10 not null, subject name voucher 50 not null, subject hour voucher 20, subject description voucher 50, teacher ID char 6 not null, class code char 10 not null, primary key in bracket subject code, foreign key in bracket teacher ID references teacher, foreign key class code references class.
Next, we run it on DB2. So the command select all from subject, we run. Okay, this is the table and the data for table subject. There are 10 subjects in the kindergarten. Okay, this is the subject name, subject hour, the description of the subject, the teacher in charge for every subject, and the class that learn the subject.
Lastly, for table group, in this table there are composite key, which is consists of teacher ID and student ID. There are 5 attributes in this table, which is teacher ID, student ID, group name, group number, group member. Okay, for the command to create table group is create table group, in bracket teacher ID char 6 not null, student ID char 10 not null, group name voucher 10 not null, group num integer, group member integer, constraint teacher ID underscore student ID, primary key in bracket teacher ID, comma student ID, in bracket teacher ID references teacher, foreign key in bracket student ID references student.
Run at DB2. Okay, we select all from group, then we run. Okay, here's the table and data in group table. So there are 4 group, which is purple, blue, green and yellow. Okay, teacher ID, which is teacher in charge for every group, student in each group, group number, and the total of member in a group.
Okay, now we are going at data manipulation language, DML, for retrieving data from multiple tables, joining database tables. Okay, question 1 state that for students that have disease, display the student ID, first name, last name, class name, and class section of the students. Sequence the result by student ID. Okay, the SQL statement for the question is, the first you must put select. Select all the attributes that you want to display as the output. Okay. So the question said to display the student ID, first name, last name, class name, and class section. So insert select s.student ID, comma, s.student first name, comma, s.student last name, comma, c.class name, comma, and c.class section. Okay, then after select all the attribute, we write from what table? The attribute is from what table? Okay, from the question we know that the output the question want to display is from table student and from table class. Okay, it involves two tables. So we put from student S and class C. We declare the student table as S and the table class as C. So that's refer from the select attribute which has S alphabet like this, S dot student ID. That means the attribute is from that student table. And the attribute that has C alphabet like this, C dot class section. That means the attribute is from table class. Okay. After from, we write where. We insert where. Where is the constraint? First, we must insert the join of the table. S.classCode equals to C.classCode. S.classCode is foreign key in the table student equals to the primary key at the table class. And okay, this one is the constraint that the question want, which is the question one for students that have disease. Okay, when the student information is not null, that means that the student have disease. Okay, and as the student information is not null, okay, order by. Okay, the question said to sequence the result by student ID. That's why we order by as dot student ID. Okay, that's all the SQL, and then we are going to run it in the DB2. Okay, this one the SQL. Okay, we are going to run. So this is the output for the question. Student ID, student first name, student last name, class name, and class section. Okay, three attribute from table student and 2 attribute from table class. Question 2 state, list teacher first name and last name for teachers that have ID T01 and T03. List also the group name that the teachers has to guide and the student ID and age for students that join the group with the teachers. Sequence the result by group name. So the SQL statement for the question 2. Okay, the first we must put select all the attribute that we want to display in the output. So the attribute we want to display is teacher first name, last name, group name, student ID, and student age. So from the question, we know that it involves 3 types of table: table teacher, table group, and table student. So we put from teacher T, group G, student S. From teacher T, we declare teacher, we declare as T, group we declare as G, and student we declare as S. That means the attribute that has alphabet T like this, T.teacher first name, that means the attribute is from table teacher. And the attribute that has alphabet G, that means the attribute is from table group. And the attribute that have S alphabet like this, S.student age, that means the attribute is from student table. Okay, then we put where. After from, where. Okay, where is the join of the table? The join T.teacher ID equals to G.teacher ID. T.teacher ID is the primary key in the table teacher equals to the G.teacher ID is the foreign key at the table group. And G.student ID equals to S.student ID. G.student ID is the foreign key in the table group equals to the primary key in the table student. And okay, this one is the constraint that the question want, which is T.teacher ID in T01, T03. Close bracket. So the question one that for teachers that have ID T01 and T03. Okay, that's why we put this constraint. Okay, after the constraint, we put order by. Order by what? The question one to sequence the result by group name. So that's why we put order by G.group name. Okay, then we put the SQL in the DB2 and then we run the SQL. Okay, this one, we are going to run it. Okay, this is the output for question 2. We got 14 rows. Okay, we have teacher first name, teacher last name, group name, student ID, and student age. Okay, now we are going at question 3. Question 3 states that for all parents that have parent ID beginning with P01, list parent ID, parent first name, parent phone number, and fee ID. Order the list by fee ID. So the SQL statement must be begin with select. Okay, before that, the attribute that the question want to display is from two table, which is table parent and table fee. Okay, so we put select distinct. We put distinct because we don't want any repeated rows in the output. Okay, so that we put distinct. Distinct all the attribute that we want to display: p.parent ID, p.parent first name, p.parent phone number, and f.vid. Okay, from table. Okay, from table parent p, vf, where, okay, where, after where, this is the join of the two table, where p.parent ID, primary key in table parent, equals to foreign key in table p, which is f.parent ID. And okay, this is the constraint that the question want. P.parent ID like P01 and then have the percent sign. Okay, this constraint, the question one, parent ID beginning with P01. That's why we put this constraint. Then order by f.vid because the question want to order the list by vid. So after we run the SQL, we will get this output. Okay, I will show you in the DB2. Okay, this is the SQL. Then we run. Okay, this is the output. Parent ID, parent first name, parent phone number, and fee ID. We got 6 rows. Okay. We are going at question 1 for simple SQL queries. Okay, simple SQL queries. Question 1 state that what is the group name and the teacher ID for group number 1 and 2? List only one occurrence of duplicate results row and sequence the result by teacher ID in ascending order. So the SQL statement must be begin with select distinct because we only want one occurrence of duplicate results rows. Okay, we don't want any repeated rows. So we select distinct, the attribute that we want to display, group name, teacher ID, from table group, from group, where, okay, the constraint that the question want, group for group 1 and group 2. So where group num in 1, 2 in the bracket. Okay, order by teacher ID ascending because the question want to sequence the result by teacher ID in ascending order. So after we run the SQL, we will get this output. So I will run it again in DB2. Okay, this is the SQL. Okay, after we run, yes, we will get the output like this. Group name, teacher ID. Only have 2 rows.
Next, for question number 2, the clerk of the kindergarten needs a listing of all subject code and subject name, except those subject code starting with letter L. Sequence the list by subject name in ascending order. In DB2, we will write select subject code, comma, subject name, because we want to display subject code and subject name. From subject, because this question related to subject table only, where subject code not like single quotation and percentage in single quotation, order by subject name ASC, because we want it to be in ascending order. Then we run the SQL command, and this is the output. Last questions for this section is, list those parents that pay the fee using cash. Display parent ID, the fee amount that has been paid, and the descriptions of the fee. In DB2, we will write select parent ID, comma, fee amount, comma, and fee descriptions. from fee, where fee transaction type equals to single quotation, cash, and single quotation. Then we will run this command, and this is the result. Next is question related to column functions and grouping queries. For question number 1, display the class code and the number of students that have thesis in each class. Name the derived column num of students. Sequence the result by the number of students that have thesis in each class in descending order. In DB2, we will write select class code, comma, count, open bracket, student ID, close bracket, as num of student. Count is using to calculate how many students that have thesis in the class. As is using to naming the column. From student, where student information is not null, group by class code, order by count, student ID, descending. Then we will run this command and we will get the output where the num of student in descending order. For question number 2, list of fee transaction types by the parents except cash with total sum for fee higher than 500 ringgit. Order the list by total sum for fee. In DB2, we will write select parent ID, comma, sum, open bracket, fee amount, close bracket as sum. From fee, where fee transaction type in, open bracket, single quotation, online, single quotation, and close bracket. Group by parent ID, having some fee amount greater than 500, order by sum. Then we will run this command and we will get the result.
Okay, for question 3, the clerk needs a list containing parent ID, fee transaction type, fee description, and fee amount for parents who paid the highest fee. Okay, now we go to the DB2 and enter the command, which is select parent ID, comma, fee transaction type, comma, fee description, comma, fee amount. From fee, where fee amount is equals to open bracket, select MAX, open bracket, fee amount, close bracket, from fee, close bracket. Okay, we need to write this MAX, which stands for maximum, because the question asks us to find the highest fee. So now we run this command and it will show you the output. So the output shows that it is in 2 rows, and this is the answer for question 3. Okay, so now we move to the sub-queries questions for question 1. List those parents that have paid fees which are greater than or equal to the average total fee of all parents. Display parent ID, fee amount, and fee description. Sort list by fee amount. Okay, we move to the DB2 and enter the commands. Select parent ID, comma, fee ID, comma, fee amount, comma, fee description. From fee, where fee amount is greater than or equal to, open bracket, select AVG, open bracket, fee amount, close bracket, from fee, close bracket. Order by fee amount. Okay, this AVG stands for average because the question asks for the average total fee. So now we run this command and we get the output, which the output shows that it is in 7 rows, and this is the answer for question 1.
Question number 2. List the parent ID, first name, last name, and job that have the same job as Megat. Next, we enter the command in DB2, which is first name, comma, parent last name, comma, parent occupation, from parent, where in bracket, parent occupation, in, open bracket, select parent occupation, from parent, where parent first name equal to Megat. And this is the output that we will get. Question number 3. List all teacher IDs with a total students in group that are greater than the average total students in group in Fathi al-Muhaimin. Sort the teacher ID in ascending. So the command that we need to enter is max in bracket group member as total students from group by teacher ID having max in bracket group member greater than open bracket select AVG in bracket group member from group order by teacher ID. And this is the output that we will get.
Okay, from this case study, the reports that we can obtain. Okay, the first one is the list of student information that registered on registration day. Second one, the total of fees that need to Fathi al-Muhaimin. Third one, the list of teachers that were involved on registration day. The fourth one, the list of subjects taken by each class. And the last one is the total of class and group in Fathi al-Muhaimin.
And the last part is conclusion. This project is designed to make more easier for Fathi al-Muhaimin to keep track data of their students. Therefore, we have developed a database management system which can store a lot of data that can be accessed by the teachers and parents. This system can cover all Fathi kindergarten management operation, which including new student registration, fee payment, information of students' parents, and student learning report. This project has been done to increase integrity of data stored in the system and eliminate data redundancy. As conclusion, we can conclude that the database management system has fully met the objective and we have overcome all the problems that occur in the existing system.